Welcome back. Let's do question 10, 10.11. A and B are independent events. Then probability of A is 1 over 3, probability of B is 3 over 4. Determine the probability of A and B. So you have to remember the product rule. For independent events, probability of A and B is equal to probability of A times probability of B. You have to remember that. If A and B are independent, then the probability of A and B is probability of A times probability of B. That's the product rule. 1 over 3 times 3 over 4, right? Then probability of A and B is equal to 1 over 4. That's the answer there. Get your 2 marks. 10.1.2. What is the probability that at least one event occurs? So what is the meaning of this? At least one event occurs. I think if I explain this using the Venn diagram, it is going to be easier. Right, so it means we can have probability of A only, that will be one event occurring. We can have probability of B only, that will be one event occurring. At least one, it means one or more. So you can also have the probability of A and B. That will be two events occurring. So A and B. So we can represent this using what? A Venn diagram. So we have our sample space, and then we have probability of A, then probability of B. This is A, this is B. Right, probability of A and B, we know that is 1 over 4. So now we were given that probability of A is 1 over 3. 1 over 3. That is the whole A, the whole circle A. Right, so what is the probability of A only? You have to say 1 over 3 minus 1 over 4, isn't it? 1 over 3 minus 1 over 4. 1 over 3 minus 1 over 4, which is 4 over 12 minus 3 over 12, which is 1 over 12. So that's probability of A only. Okay. Then what about the probability of B only? Probability of B is 3 over 4, the whole circle, B, 3 over 4. So now you have to say 3 over 4 minus 1 over 4. 3 over 4 minus 1 over 4 is 2 over 4, which is 1 over 2. So probability of B only is 1 over 2, right? And then if we subtract all these three fractions from 1, you will get 1 over 6. Okay, these are not A, not B. What's the probability of at least one event occurring? So it can be A only, it can be A and B, it can be B only. So we just add these three. And then this section, if we check this, that is probability of A or B. That's probability of A or B, right? So we can add these and say 1 over 12 plus 1 over 4 plus 1 over 2. You add those, you will get what? You'll get 5 over 6. Right? The other thing you can do is to use the addition rule. Remember, probability of A or B is equal to probability of A plus probability of B minus probability of A and B. Okay, so it's going to be 1 over 3 probability of A plus probability of B, 3 over 4 minus probability of A and B, we got it here, it's 1 over 4. And then what do you get? You get your 5 over 6. All right, 10.2. The probability that it will snow on the Drakensberg Mountains in June is 5%. When it snows on the mountains, the probability that the minimum temperature in the central South Africa will drop below 0 degrees is 72%. When it snows. And then if it does not snow on the mountains, the probability that the minimum temperature in central South Africa will drop below 0 degrees is 35%. So we have two events here. The one about snowing and then the other one about the temperatures, right? So it says, represent the given information on a tree diagram. Clearly indicate the probabilities associated with each branch. So let's represent these events on a tree diagram. We have the snowing part, so is either it is going to snow or not snow. So let's use S for snowing and NS for not snowing, right? So the probability of snowing is 5%, so it's 0.05. So what would be the probability of not snowing? Is going to be 0.95. Remember, these must add up to 1. The probabilities on the branches must add up to 1, right? And then this point, if it snows, means you're looking at this branch. If it snows, then the probability that the minimum temperature in the central South Africa will drop below 0 degrees Celsius is 72%. Let's say just below 0 degrees Celsius, right? That is 72%, so it's 0.72. What about not below? Not below 0 degrees Celsius. That would be what? You say 1 minus 0.72, you get 0.28, right? And then this point, if it does not snow on the mountains, the probability that the minimum temperature in central South Africa will drop below 0 degrees Celsius is 35%. If it does not snow, then the probability that is below, the temperature is below 0 degrees Celsius is 35%, 0.35. So the probability that is not going to be below, not below 0 degrees Celsius is going to be 1 minus 0.35, that is 0.65. So that's the first part here. We have answered the first part. Represent the given information on a tree diagram. Clearly indicate the probabilities associated with each branch. Done. 10.2. Calculate the probability that the temperature in central South Africa will not drop below 0 degrees Celsius. Will not drop. So let's look at the branches where there is not below 0 degrees Celsius. This is the branch. This is another branch. So remember that along the branches we multiply and then different branches we add. So we're going to have 0.05 times 0.28. Right? This is this branch, this branch, this branch. Then plus this branch is going to be 0.95 times 0.65. Right? Then just put this in the calculator. You'll get your 0.6315. This is 10 to 2. Let's do 10.3. 10 learners stand randomly in line, one behind the other. In how many different ways can the 10 learners stand in the line? So let's say about 10, 3, 1. So we have 10 learners, one behind the other. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 learners. Okay? Right. They're standing one behind the other. Right. So it means the first slot, we have how many choices here? So we have 10 choices here. Okay? So this is 10. If the slot is occupied by the first learner, we're left with how many learners to occupy the second slot? 9. 2 learners have occupied this slot and this slot. We're left with how many? 8 to occupy the third one. 1 learner there, 1 learner there, 1 learner there. We have 3 now. So we're left with 7 learners. We have 7 choices here. 1 learner, 1 learner, 1 learner, 1 learner. We have 4 learners. So we're left with 6 learners. It goes on like that. Goes on like that. 4, 3, 2, 1. This is actually 10 factorial. This is 10 factorial. So that's the answer there. How many different ways can the 10 learners stand in the line? That would be 10 factorial. Then 10, 3, 2. Calculate the probability that there will be 5 learners between the 2 youngest learners in the line. Right? There are 2 youngest learners, and then there should be 5 learners between them. So let's look at these different situations. Right? We can have a situation. Let's have these slots. Let's say we have, there are 10 of them. Let me put them like this. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? If one of the 2 youngest learners occupies the first slot, so the first slot is going to be having 2, and then that is for the youngest learners, the 2 youngest learners. And then we have 1, 2, 3, 4, 5. And then this slot, we have only one choice. The first slot, we have 2 choices. Then if one of them occupies the first slot, then we only have one choice for this other slot, which is slot number what? 1, 2, 3, 4, 5, 6, 7. Slot number 7. Okay, because there must be 5 learners between them. Right, let's go to the second situation. We'll fill in the rest later. right? The second situation will be like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? So we can have now this slot and this slot. The youngest learners occupying slot number 2 and slot number 8, isn't it? So in slot number 2, we have two choices, right? So if one of the two youngest learners occupies slot number 2, then we only have one learner to occupy slot number 8. Okay, like that. Still, there are 5 learners in between them. Third situation: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? So they can take slot number 3 and slot number 9. Right? So we have two choices here. If there are two of them, it's two choices. And then if one of them occupies the third slot, then we only have one learner to take the ninth slot. That is for the two youngest learners. We only have one there. Okay. And then the last situation now will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? It can be the fourth slot and the 10th slot. So here we have two choices because there's still two of them. If one of them takes the fourth slot, we only have one learner to take the 10th slot. That is amongst the two youngest learners. Now, let's go back to our first situation. The two youngest learners have taken the first and the 7th slot, isn't it? So we're left with how many learners? We're left with 8 learners now out of 10. Right, this slot we have 8 choices. So now if how many learners that have occupied the spaces? 3. We're left with now 7. 7 choices. We have how many learners now? 4. So we're left with how many choices? 6. We have how many learners now? 1, 2, 3, 4, 5. We're left with how many learners now? 5. 1, 2, 3, 4, 5, 6. So it means we're left with 4. You see that? We have 1, 2, 3, 4, 5, 6, 7. So we only have 3 to choose this one. We now have 8 of them. We only have 2 to choose this one. And then the last one, only have 1 to choose that one there. Okay, right. And then the second situation is still same thing. We have 8 learners because we have 2 there, 1 there, 1 there. So we have 8 learners to choose this slot. We have 7 learners to choose this one. 6 there, 5 there, 4 there, 3, then 2, then 1. The third situation, 2 learners have taken these slots. So we have 8. 3 learners have taken the slots, so we're left with 7, like that. It goes on like that. Then we have 6 here, we have 5, we have 4, we have 3, we have 2, and then we have 1. Okay. Then 2 have taken the slots, so we're left with 8, so it's 8. 3 have taken the slots, so we're left with 7, 7. 4 have taken the slots, so we're left with 6. And then 5 have taken the slots, so we're left with 5. 6 have taken the slots, so we're left with 4, like that. It goes on like that. 3, 2, 1. Then if you check in all these 4 situations, the numbers are the same. We just have to say 2 times 8 times 7 times 6 times 5 times 4 times 1 times 3 times 2 times 1. It's just the same numbers. So that maybe they're differently arranged, but they are the same numbers. So if you multiply this, the first one will give you 80,640. This one will also give you 80,640. This one will give you 80,640. Then 80,640. Then you can say 80,640 times 4. What is it? So the total arrangements will be 322,560. Right. But the question says, calculate the probability that there will be 5 learners between the two youngest learners in the line. So if there are 5 learners between the two youngest learners in the line, this is the number of the total arrangements. But what is the probability then? The probability should be 322,560 divided by, we got this 10 factorial. Okay, then the answer is what? 4/45.